All right, ladies and gentlemen, thank you for tuning in. Of course, today we're going to be looking at 5 NBT5, which is multiplying. And we're going to start off today by doing a 2-digit number by a 1-digit number. Now, first, I want to go ahead and show you a couple of videos explaining 2 different strategies that we, of course, are going to look at. These strategies, of course, will then be used to help develop the standard algorithm or the long multiplication way of solving a problem, okay? All right, so let's get started.
In this video, we're going to dig a little bit deeper and try to understand how we might multiply larger and larger numbers. And in particular, we're going to focus on multiplying 2-digit numbers times 1-digit numbers. So I always encourage you, pause this video and see if you can have a go at this. Try to see if you can figure out what 37 times 6 is with some type of method. All right, now let's try to come up with a method ourselves. So one way to think about it is the different places. So this 3 is in the tens place, so it represents 3 tens. And this 7 is in the ones place, so it represents 7 ones. So you can break up the 37 right over here as 3 tens. I'll write it like this. 3 tens plus, and I'll do this in yellow, 7 ones. And then we're going to multiply that times 6. Now, another way you could think about this is the same thing as, I could rewrite this as 3 tens is the same thing as 30, and 7 ones is, of course, just the same thing as 7 times 6. And you could also view this, and you could call it the distributive property if you like, or I really want you to think about it, why it's intuitive. If I have 37 sixes, that's the same thing as 30 sixes plus 7 sixes plus 7 sixes. And I'll put the parentheses there just so we can keep track. Once again, 37 of something is equal to 30 of that something plus 7 of that something. 37 times 6 is 30 times 6 plus 7 times 6. And then we can figure these out. What is 30 times 6? Well, 3 times 6 is 18. So 3 tens times 6 is going to be 18 tens, which is the same thing as 180. And 7 times 6 is 42. And we just then need to add these 2 numbers, and we could think about them in terms of the different places. We could look at the ones place, 0 ones, 2 ones, so that'll give us 2 ones. And then we can think in terms of the tens place. So we have 4 tens and 8 tens, so that is going to be 12 tens. We could write that down as 120. And then we only have 100 right over here. So we don't have a hundreds place over here, so I'll do 100. And if you add these together, 100 plus 120, you add the hundreds, you get 220. And then you add the 2 ones, you get 222. So this is all going to be equal to 222. Now, this isn't the only way to approach it. We could actually try to do it kind of like this, but we could write things so it's a little bit easier to keep track of. So I could write, let me write it this way, 37 times 6. And I'll view this column here is where I want to write my ones places, and this column here is where I want to write my tens places. And if hundreds places show up, I'll write it over there. And that's just really to keep track of things. And then I can do the same thing. I could take my 6 and I could say, all right, this is the same thing as 3 tens times 6 plus 7 ones times 6. And I could do it in either order. Let's do the ones first. So if I do the 7 ones times 6, that's going to be 42. 4 tens plus 2 ones. How did I get that? That is 7 ones times 6, or 7 sixes. That's how I got this number here. And then we could multiply our 3 tens times the 6, which we did over here. So 3 tens times 6. Well, that's 36s, which we already know is 180. 1 in the hundreds place, 8 tens, 0 ones. And now this makes it a little bit easier to add everything together. Exactly what we did at this step right over here. Everything is in the right place value, so it's easy to add them up. So 2 ones plus 0 ones is going to be 2 ones. 4 tens plus 8 tens is 12 tens, or 102 tens. So I could put the 2 tens here and then put that 100 up here. And then 100 plus 100 is 200. So there you have it, 222. The whole point here, though, is to really appreciate what is going on, that we're just breaking up the 37. We're breaking up this 2-digit number into its places, the 3 10s, the 7 1s, and then we're multiplying each of those times the 6 in this situation. And we did it both ways. These are just different ways to write the same, really the same method.
All right, ladies and gentlemen, so of course is looking at partial product. I want to show this one now. And this is looking at something called the box method, also known as the area model. All right, so let's take a look.
How can I multiply 2-digit by 1-digit numbers using the box method? Let's take a look. So right now I have the numbers 23 times 4. Before I can do any multiplication yet, I'm going to actually break my numbers apart. So let's do some arrows. So I have to look at what does a 3 really mean when it's in the ones place? Well, a 3 in the ones place really does just mean 3. But what about this 2 right here? What does that 2 really represent? Does it represent 2? No, it really represents 20. And then because I have a 4, it's single on its own. I don't need to pull it apart. So now what I'm going to do is I can see that one of my numbers breaks into 2 and the other one has 1. So I'm going to put the 1, the number that breaks into 1 digit right here, and then the number that breaks into 2 digit over here. But to do that properly, I'm going to divide my box in half. And now I'm going to bring over my numbers. So I have 20, I have a really big 3, and then now I'll include my 4. Now what I'm going to do inside of each of these boxes is just multiply the 2 numbers that are on either line. And one of the nice parts is if it ends in a 0, all we really have to do is multiply the first digits. So what's 4 times 2? Well, that's, let me get my typing tool, 8, and then I just add in a 0. So there's the first part of my problem. 20 times 4 is actually 80. Now what's 4 times 3? Well, we know that 4 times 3 is 12. I'm only halfway through my problem so far. I have 2 different numbers in here right now. So I'm really going to do is I'm going to take each of them, and you don't have to pull it out of the box, obviously. But I'm going to take those 2 numbers, and now I'm going to add them together. So let's see if I can get my little addition really fast. There we go. So let's see. 0 plus 2 is 2. 8 plus 1 is 9. So my answer is, in fact, 92. Let's try the next one. All right, here we go. We have 42. So I'll go ahead and divide the box in half. And I want you to take a moment right now to think of what 2 numbers does 42 expand out to be. You said 40 and 2. You're right. And we can just keep the 5 on the side. All right, so let's take a look at our first box. We have 40 times 5. So we can see this as what's 5 times 4. 5 times 4 is 20, and then I'll include my extra 0. So really, it's 200. 40 times 5 is 200. Next, we have 5 times 2, and 5 times 2 is 10. So do you guys remember what we do next? What is it? If you said add, you are correct. So now I'm going to take 200, I'm going to take 10, and I'm going to add them. I'm sure you guys know that 200 plus 10 is 210. Good job, guys.
All right, so hopefully, of course, got the gist of that. Now I'm going to go ahead and show what we're going to talk about. All right, so definitely take a look here. Okay, all right. So what we have, of course, is our standard that we're definitely going to talk about, and that is 5 NBT 5. And that is being able to multiply a 2-digit number by a 1-digit number using a variety of strategies. Okay. So, and of course, you see there I have a multiplication chart on the left-hand side. I have an anchor chart, which is discussing multi-digit multiplication. There's some vocabulary words there. There's a definition for multiplication. There also is traditional algorithm, which is considered the standard algorithm. And then we have two other ones that we're really going to also focus on besides the standard algorithm. That is the box method or the area model, and also partial product, okay? We're not going to talk about the lattice method, but that is another method that can be used. And of course, on the right-hand side, we have the multiplication tables 1 through 12 as well listed out, okay? All right, so let's take a look. Some key vocabulary that I want you to, of course, write down and focus on is, what is multiplication? Multiplication is a mathematical operation. Again, whereas four operations, we have addition, subtraction, multiplication, division, right? There's the order of operations that we discussed last week, which is looking at parentheses, exponents, multiplication, division, addition, subtraction, right? But our four primary ones that we look at is addition, subtraction, multiplication, and division. So a mathematical operation that is performed on two or more factors to find the product. It's also known as repeated addition. So you could do addition facts and addition and just keep repeating it, but that may, of course, take a longer time. So multiplication is considered easier. Notice I have two words that are in red, factors and product. So I want to state what those are. Factors, ladies and gentlemen, are numbers that are multiplied to find the product, okay? Whenever you have numbers that are being multiplied, those numbers are considered factors, okay? Those mathematical term. And of course, what is a product? A product, ladies and gentlemen, is the answer to a multiplication problem. So feel free, you can pause this at any time to copy down these definitions, okay? So let's keep things moving. Here is one problem. Again, I'm going to do this for you, so hopefully you can get a better understanding than just having had watched the videos. All right, we're going to look at the box method, also known as the area model, and also partial product, okay? Same problem, just two different strategies, two different ways. All right, so with the area model, we have to think, why is it called the area model? The reason why it's called the area model is when we deal with area in math, we are looking at two measurements. We're looking at length, and more than likely, we're looking at width as well. Sometimes people say length and height, okay? But we're going to stick with length and the width, okay? And if it is area, that means that we typically want to draw a rectangle, okay? Which is helpful for us. If we see a rectangle, although we know that there is a length and there also is a width, depending on how you look at it, or height, okay? So two dimensions. So that being said, we're going to now decompose our two numbers that we have, okay? We have 19 and we have 3. Now, 3, of course, is a single-digit number, so I'm going to write that over here, okay, on the smaller side. The longer side, we're going to decompose 19. So what I'm going to do, before I even do that, I'm going to go ahead and split my rectangle. You could split it in half, right? You could have one side a little bit larger than the other, but nonetheless, I'm going to talk about that in a second. So let's decompose 19 into what would make up 19. That would be 10 as well as 9, okay? And we, of course, are going to multiply those values to the 3, okay? 19 being a factor, 3 being a factor. Another way of saying that is I have 19 3 times, okay? So let's take it one by one. So we have 10 times 3. That, of course, is 30. Our next box, 9 times 3 is 27. We now take those two numbers, and we have 30 plus 27. We then end up with 57 as our answer. So 9 times 3 equals 57. Now let's do the same thing, but use the partial product, okay? So partial product simply means we're taking parts of our number, and which, of course, are products, and we're going to form it and put it together. Now, it gets a little bit trickier when it comes to more than one digit being multiplied by more than one digit. For example, tomorrow you will see a 2-digit being multiplied by a 2-digit. The next day you will see a 3-digit being multiplied by a 1-digit, and then a 3-digit by a 2-digit. 3 digits being multiplied by 2 digits is the farthest that we are going to go in 5th grade. Okay, so no need to worry. We're going to take it day by day, all right? So let's look at this. Okay, the first thing I want to look at is, okay, I have 19 times 3, so what does that mean? That means I have 9 times 3, and I also have what makes it 19. I have 10 times 3. So 9 times 3, of course, is 27. And then 10 times 3 is 30, right? Again, I wrote the ones place first, so I have an idea. Okay, I'm going to add those two together, and sure enough, I get 57, which is the same answer as I had before. Now, partial product, ladies and gentlemen, is very similar to standard algorithm, and that's what we're going to lead up to, okay? Come middle school, you are, of course, required to know standard algorithm, but like I told many students is this. I'm showing you the strategies that you are going to see. Now, I personally don't care which strategy you choose to solve if you just have a problem, such as 19 times 3. However, if you have a question that gives it in the form of the area model and a number is missing, you have to know what you would have to do to fill in that number. That's why I'm showing this to you, okay? So let's try another one, okay? We have 16 times 5. So let's do the area model. Let's also do the partial product, okay? So we have 16 times 5. So first, I want to go ahead and draw a box, a rectangle, right? Which is helpful. Okay, I'm going to split that. All right, so I'm going to have some values at the top and values on the bottom. I'm going to decompose 16 to two numbers. So think of it as two columns, one row. So that becomes 10 and 6. And then here would simply be 5. All right, so 5 times 10 would be 50. 6 times 5 is 30. You add, of course, those two together. 50 plus 30, of course, is 80. Okay, now let's look at it with partial product. Okay, again, I'm going to look at it as 6 times 5 and then 10 times 5. Okay, so 6 times 5 is 30. All right, 10 times 5 is 50. All right, I solve that and I get 80. Same answer, okay? So again, I want you to choose which one works better for you. Maybe you feel area model is really helpful, and I understand that. Great. Now, as we go throughout the week, you're going to start to see boxes increase, meaning if we're doing a 2-digit by a 2-digit number, we're going to have 2 columns as well as 2 rows. Okay, here we have 2 columns and 1 row. So the boxes will, of course, increase. If we're doing partial product, we're going to end up having more products, okay, and then piece it all together. All right. Well, I hope you got the gist of this so far. Again, let's keep rocking it out, and we're going to do really well. Take care. Strive for greatness.